We have Dwayne Stenlund, Senior Natural Resource Program Director with Minnesota DOT, is Certified Erosion and Sediment Control Professional with 28 years of experience. He's applied sustainable technologies in road and bridge projects to address soil and stormwater quality challenges. Dwayne frequently presents across the U.S., including annually at the International Erosion Sediment Control Association Conference, and holds a master's in plant biology from the University of Minnesota. So the stage is yours, sir.
I would use, we say 85% sand, because the qualifying figure is a drainage has between 1.6 and 8.3. You have to bracket it. So then I might have 10% compost by volume now, and 5% char, and then I might have 5% compost, 5% char, and 5% iron enhanced. You know, it's been I got phosphate leaking, so it's like a chocolate chip cookie. But it's almost always 85% concrete wash sand. Because it has to drain, and it has to drain in 48 hours, or it's a redo, and they're almost $250,000 to redo them. Great fun. Thank you for coming. I'm a strange person. I don't have any research. I have a lot of feelings. I've tried a lot of things. It's kind of dump and go, and that's what I'm going to talk about today. So it's the idea of wishful thinking or the future. And I had a whole lot of slides, but they thought I had too many, but I was confident I could still get it through, so we'll find out. But part of my background was, if you remember, we had a bridge fall down in Minneapolis. It's safe to drive on, you're good to go, and I was assigned this project. I don't normally have this kind of stormwater pollution prevention plan design, but this was weird, and part of it is that when the bridge fell down, it broke into a Superfund site that was left behind by the railroad person named James H. Hill. And it was a gasification pollutant area, and that's what we punched through, and mercury was the main pollutant of concern. So those orange things that you see there were, I'm using what's called, they called it a ceramic peat, but I'm pretty sure it was biochar. We didn't have the word biochar in our lexicon, and so they basically used high temperature peat, and it was designed to trap all divalent cations, and that was what I wanted. So there was a really cool stuff, and the MnDOT let me put it in sleeves, so I had it everywhere. But it was only because the federal government paid for everything. Otherwise it'd have been fight, because I didn't have it as a standard for this. But that's what I did, and so that was the beginning of using three-dimensionality of things to try to remove pollutants in a flow line. And so I need your help, and this is where I'm going to burn up some time here, but I've asked everyone on planet Earth, do you have a design manual? Do you have a design manual for maybe one topic? So we just heard maybe on some bio-retention stuff. Okay, fine. But I can't find much of anything. And if we're going to make progress in using biochar in the world, you've got to start with good design. Because if it ain't in the plan, it ain't going to happen. You can argue all you want. You can give it away for free, and I still won't put it in. It's got to be in the contract. So do any of you know biochar standard specs? There's material specs. You all have something, but there's nothing uniform. And USBI's work, everyone is working on it, but no one talks to nobody, as far as I can tell. We're all little islands. And then, as soon as you've got a design guidance, get it in contracts, estimate the engineer's cost of it. I have material specs, now I gotta figure out how to install it and how to pay for it. You see, I live in the low bid world. I'm construction, I'm the DOT. So if it ain't in the contract, it ain't gonna happen, and someone's gotta bid it. I don't do any work, I'm just, one of those, I yell a lot, scream a lot, and I do a lot of technical support, but I don't actually do any work. I'm just, goofing around. It's great fun, it is, but I have to pay for it because nobody does this for free. And believe it or not, I'm really not that concerned about what it costs, because if it's solving a problem, it's the right cost. You all think, I can't do it for $500 a ton. Oh, come on, you're wrong. Either it's working for solving something or it isn't. But if it don't solve the problem, don't worry, I'll never use it again. It's that simple. Screw it up for me and I'll never use it again. That's why I live and die by standards. Engineers have a problem, you use a specified material, and it either works or it doesn't, but if it don't work, we're not doing it again. Even though we did it wrong. I love it. Maybe it's 4 R's, maybe there's 5 R's. Righteousness might be the another R here. And so if you're interested, and if you have information, please consider talking and taking a survey. So I've got a research project where I hired a consultant to find, does anyone on planet Earth, I'll even take the universe if you've got something from Mars or from Venus or any place in the universe, I'll take that. But I really am looking for, do you have anything on how to design for it? You just heard it from earlier, for landscaping, for stormwater, for the myriad of things that you just mentioned. But it don't happen by just love and luck. In fact, there's no love in my world. It's work, and it's called work for a reason. You don't go to love. How many came here today for love? Okay, one. Yeah, I know. A couple of you, yeah. I could use a hug, I'm telling you. So I have a spec. I don't care whether you like it or not. And the moment I write something at the DOT, y'all hate it. But you have to write something for you to hate it, right? So until I write something, so there's no specs that I can find. So what I have is class 0. It could be grade, it could be another name, but right now I'm calling it a class. It could be a type, so men that always labels things. And that's no testing area. So it's the same feedstock. It's always going to be hardwoods at this point because that's all the research that I've got from Dr. Brian Berry, and we've got a representative here. And then class 1 is maybe for road base and pavements. That might still be true. And you'll hear presentation. There's even someone from concrete here. Maybe he left already on me. And then the general soil additive or general additive. So that's class 2, and that's what I'm going to talk about for temporary sediment control. But that would be just something as a soil amendment. I'm not going to ever get credit for anything. Get over that. It's solving a problem. And if the contractor might get some CO2 credits for installing in a construction, but MnDOT won't because it's a state agency. And then I've got 2 classes of 3. 3A is nutrient-enhanced additives. That's different than just adding it to soil and hoping. And each time you'll see, and you can't read it, but I'm testing for more and more things. As you test for more things, like all the EPA heavy metals and PCDDs and all those other things, the cost goes up. And then class 3B is stormwater, and that's the highest level of testing. So maybe the same pyrolysis, and I don't even ask for the temperature. I ask for other variables that are more indicative of what I'm getting as a finished product, and I boiled it at 600 Celsius for 2 minutes. I've heard some crazy numbers. You don't know that. And then I heard someone say they dug a hole in their farm field and then burned it, call that biochar. Well, what temperature did it get at? Now, there's some really neat industrial things that spin and, curtain, flamey things, and all sorts of cool stuff out in the show. But, most of these flame things, and, no, you don't really know. But it might be just fine for class 0, 1, and 2, but not for 3. You need more data, and of course, as the testing goes up, the cost goes up. But then it's supposed to be solving a problem. All right, so now we're finally getting into what I'm supposed to talk about. That was my commercial. You got any cool things, let me know. And we have active systems when we're dealing with contaminated soil, so I'm using biochar in projects that have excessive contamination. I'll say more about it. So sometimes we put it into a pond that will get contaminated called road runoff. Copper, zinc, chromium, cadmium, everything that comes out of a tailpipe, everything that comes off of a car. Over time in Minnesota, we rust a lot of things, so by the time you're done driving it, the rubber's gone, the road's gone, and the car's missing. It's all someplace, though, because roads wear out, tires wear out. It all goes someplace. So 6 ppdq is going someplace. And then the idea of passive systems, and I'm going to be focusing today on chemical trapping. So filter logs, soil coatings, and soil covers. And I'll give you a whole bunch of things that I want to do or plan on doing and have no idea if they work. Because I can't get anyone to research it, because you then want money to research. You won't do research for me for free. Isn't that weird? And you actually want to get a pretty good wage, not minimum. Well, it'd be fun to have Dr. Berry working at minimum wage, eh? Yeah, that ain't going to happen. So in most projects where I've got known contaminants, so as we drill a lot of holes, find all the contamination, I might have these metals as an example, and we label the soils green, yellow, and red. Can you tell me what you think red soils mean? Bad. You can't reuse it. Yellow is bad, but it's reusable. So you can entomb it into the road base, behind concrete walls. We're never growing tomatoes on a roadside. So it isn't one of those things. I'm not supposed to be playing there. So hopefully parents are watching their children, because I don't think you should be playing on the freeway. When I was growing up, my dad said, go play on the freeway. You're all younger than that, I know, but You know, the way of getting rid of me, go play on the freeway. At least someone laughed. That's thank you. I appreciate that. So this is a sign. This is a real project. It's in the Duluth area. It's an old industrial corridor, railroad, and everything started at the beginning of Duluth. We have the same thing in Minneapolis. Industry started, and we didn't have a lot of pollution control, and things happened. So anyway, that's an example and of what I'm having to deal with. And then we make maps. Now, I know you can't read it. Now, you can complain all you want. But what the map is for us in construction. So you'd look at it and say, oh my goodness, I've got a certain color says mercury, certain says hydrogen lead, one might be say arsenic, one might be say DROs, diesel range organics, gasoline range organics, VOCs, PCBs, and now we're going to add PFOS to it. You know, we're just not done adding the stuff. Well, that's what we have to deal with. And if the thing drains to a hole, the soils, if it gets contaminated groundwater up wells or rainwater falls into it, we have to treat the water. We basically bring in portable water treatment plants. I'll show you that. But what if the water can't go in the hole? And I know America loves this kind of thing because it's what I see. If you don't test it, it's safe. So it's best not to know. But when we do know, then we got to respond. So these are examples of plumes. And this is a real project, Front Highway 10. If you go to Moorhead, you can't miss it. It's under direct construction right now. And you know, things happen. And then you got these things that look red like a target. Ooh. You know, that means this bad stuff is migrating. Oh, isn't that fun? So we bring out a water treatment plant. And the water treatment plant consists of something like this. Uses a lot of electricity, 430 volts, 3-phase. I mean, when you turn that thing on, this whole city turns dark. You know, it's a big, a lot of energy use. But we have to go through, and you'll see in here we've got sand pods, we've got chemicals called flocculates, reverse osmosis, we've got activated carbon, not biochar, but activated carbon, going through various settling tanks, you've got oil water separators. You know, basically what you're looking at here is $7 million. This is one project. Huh. That's just for the water we can get. So again, I just showed you, these are all the connected things. It's all on a bunch of trailers. It takes an expert to set it up. And hopefully when you're done, you get the water clean enough to meet federal standards to go to the sanitary of the city. You still can't go into stormwater. It's an entirely different permit. And you guys are worried about some biochar in a farm field and a few places over here. This is my world. Now when I'm done, how many think the soils are still contaminated? All right, well, that's some of you are shaking yes. So not all the water can be treated, you know, put it into a hole, because you have to drive into the project. So far, we don't use Google to build any project, so you don't just helicopter in and helicopter out. You got to drive in, you got to dig soils, haul them out, and stuff falls into trucks, falls out of trucks, falls on tires, falls all sorts of places. So I've got to deal with exits. I've got to deal with haul roads. Slopes and perimeters that don't drain back into the hole that I can pump and treat. It drains, curb, gutter, pipe, and river. Huh? Stockpiles, you got stockpiles, you don't just build, you got to put stuff over there and you construct around. And then I have a whole bunch of other things, you know, like the city's stormwater, and we connect to those. You know, we don't just have our own pipes, we connect to other people's pipes. And then, how many have seen a building being demolished? Or a bridge being demolished? Oh, isn't that fun? Blow the sucker up. Oh, goodness, that's man, that's so much fun. But how many think it generates a lot of dust blowing up a bridge, a building, say in downtown Minneapolis? So they use water. But you remember, that building could still have asbestos in it, you know, mercury, and all sorts of other groovy, cool things, and then use water. Now you got water all over the place. And where does water go when it rains that you've just put on the ground for dust control? Well, someplace. Of course it does. So here's an example, and you don't know what you don't know what you're looking at, but I'm going to tell you. And this is an example where the yellow soils, our red soils, would go. So it's a stockpile that meets the EPA requirements. So it's got a plastic liner, high performance perimeter control, not wimpy stuff, and then data cover. So when you can't do a direct haul to the landfill that'll take this waste, you've got to store it someplace. Well, have you ever seen a contractor get it all right all the time? Like it'll never rain, it'll never blow in. So plastic blows off, I'm tired. And things. So now I'm driving a truck in there and I'm putting what kind of dirt on the tires when that's full of regulated arsenic soil, contaminated? I'm tracking it all. But not to be done, I'll take a sweeper then. And no sweeper's ever been invented for construction track out. It's good for relief and grass clippings. It's really good for MS4, but it doesn't do nothing for dirt pickup. It's a good smearing device though. Oh man, it smears good. So, well, here's an example. It just happened to rain. Same contaminated stockpile area. What do you think that soil consists of, and how do you think I'm supposed to handle it? La, 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 live for today. Remember, I hear nothing, see nothing, speak nothing, right? So what are you going to do about it? Well, you don't live here. Whoa, that was a good one. Man, that was close. I could have been contaminated. Their children, their families. So this is where the biochar would go. They'd be incorporated into these soils, and this temporary, and when I'm done, it goes back into the pile, and you haul it away and bring up some more char. How long does the char last before all the arsenic, lead, mercury, chromium, VOCs, PCBs are abstracted? I have no idea. Nobody wants to test for that, so I just put some down and replace it. Then I have a rule, but I don't know if it's a good rule, but I'll say that for every 2 inches of accumulated rain, you replace the media. It's a number, and I can enforce that because we do know it rains sometimes in Minnesota. Okay, I'm taking some buildings down. What does that look like to you? Is that a solar eclipse? Well, actually, that's a sweeper. That's the sweeper. That's what it looks like after sweeping coming out of my contaminated stockpile area. I'm just showing you the picture of the high-performance perimeter controls, plastic wrap jersey barriers, all these fun things. But does that look good to you people? So then I should be using water, a lot of water, and I should be pre-wetting the road and then picking up. But how efficient are street sweepers when studies have shown no better than maybe 8 to 10%? Doesn't it imply that 90% of something is still getting away from us? So prevention is the key here, but I still got to drive in and drive out. So then I build pipes, and this could be in contaminated soil, and that's what they call a bulkhead. How many think that bulkhead's working? Would never let regulated or contaminated soil sneak out of this project into the receiving waters, right? Well, that's construction. Boy, that's good looking soil too. Woo-wee. And then that's also contaminated where you have to use plastic liners under our stormwater ponds. We don't just get to build ponds, we got to put liners under them, then put the media on top. And how many think that there's soil that got into that? I haven't even got it constructed or your thing bricked in and sealed, and off it goes. So I'm just showing you the picture of the lower right, and the big one, that's one and the same, and that is a contaminated soil area. It might be just diesel range or gasoline range organics and VOCs from leaking gas, fuel station pipes. Who knew that those things leak over time? And then we build on them. And then I have to protect some inlets, and some inlets are much nastier than others, and have a lot of weird stuff that contractors forget that pipe could be asbestos coated. It could be, no one really thinks about this. What we're here to build. There's no money in resource protection. And then I have to demolish things. How many think when you've got old boilers that you might have wonderful, cool things coating them, and then you sort of remove what you can, and then you tear the whole thing apart, haul it to another landfill that will take that kind of waste, but you still had to use water and other, oh, wait a minute. Okay, now you're starting to get a sense of the problem. And so this is where temporary, and I want to say thanks to Nick. Maybe Nick, you could stand up for me, because I have to beg for good people to say, yeah, Dwayne, I'll help you. And he took biochar, stuck it in a log, and there it is, the red one. And then another Nick Ralston, who couldn't be here today, from a university like University of North Dakota. He's even willing to go and test it to see if I trapped anything. This is a dump and go. I don't know if it works, but I know doing nothing isn't an answer. So then I tried to develop what we call a stormwater pollution prevention plan, and it's an amendment. So I take those contaminated areas and try to develop how to get in, how to get out, where the water goes, and develop BMPs, best management practices, to try to absorb that pollutant. And these are the hot spots. So there's little scale things that you see here. So you might see on every one of them, it probably has arsenic listed, ethyl benzene. I mean, just groovy things that. How many used to listen to the Doobie Brothers? Or the, Anyway, I was one of the few that inhaled, apparently. As a 60s person. So what I need is material performance properties, because I want to use it temporarily mixed with sediment control, 3-dimensionality. So I'll mix it with compost, I'll mix it with wood chips, I might mix it with sand, and use them as temporary perimeter control to absorb the pollutants that may be washing towards me in areas that I can't get back into the hole, where I can pump it to the water treatment plant, scrape it up, and it goes to the landfill. So I don't know how long this stuff lasts. I really don't know whether it pulls the metals that I think it does. I think it does. Evidence would say so, but You know, this is where the infancy. So how many think it's better to try something than to wait? Because by the time I know, I've already had a lot of projects get done. So I'll start with trees, grind them up, and use them for temporary erosion control. I use it for exit control, perimeter control, all sorts of things. So the trees gave up their life. And then what I'm proposing is when I'm done, take the excess woody debris and charify it, and then put it back on the landscape. Whoa, isn't that cool? So I make monster piles. So we have bats in Minnesota, and I can't take the trees down when the mama bats might have baby bats and doing mama and baby bat communication and bat things and bat stations, and I don't know. No one watched Batman either. Stay tuned next. Well, anyway, so I use it for a lot of things, everything. So trees gave up their life, use it for temporary control, incorporate it into the soil, and then charify it. So the next one here is the idea of soil amendments, but for me, I'm going to use that class for the engineering controls, and what you'll see again is that for perimeter controls. So the green one, in this case, and the black colored ones, it's just a fabric, are the wood chip ones, and the red ones are the biochar enhanced sediment control log. So I want them in front of the sediment control. So these are pollutants along for the ride. So in theory, if you were able to remove the sediment load, that's why three-dimensionality, if to remove the sediment load, you should be removing the heavy metal. And if it is an organic material, I hope that wood chips should absorb the gasoline and diesels and things like that. And hopefully the chewable bugs would just say, oh, food, baby, you've just fed me. And that char just comes alive with the organisms. Can't you just hear them? I didn't say I was normal. And so just an example, again, regulated soils, contaminated soils, and trying to put these logs in strategic locations to treat that water where it only ends up in a curb gutter. In this case, in all cases, it's going to a resource, and you might know it as the Mississippi River on the big picture. And the other one is the Red River in the upper left, and the other one is one of our rivers in the northeast part of Minnesota, part of the Gunflint Trail. So then inlets, and this is where, again, I need help. We want to talk about innovation. Could we take char and put it in a pillow, and then put it on some sidebars, like my little doodlement here, and then put that as an inlet insert, and I'll have a char-absorbing filter thing that would take the pollutant that sneaks through the inlet that got away from my ring of biochar life, and still have as a char-absorbing material, or something that might be for more liquid spills or volatiles or something. Because that's my last line of defense. Once it's in the inlet, how many think it's lost? How many think it's never recoverable again once it's in the conveyance pipe on its way to the river, wetland, lake, whatever you have, or the Chesapeake Bay? I mean, once it's there, good luck getting it out. We know we can't. So then how about could I use char mats? So you're looking at exit controls, could I add the char layer and keep adding it? You know, the exits wear out, but could I keep adding char to the layer? Not that I'm maybe doing much, but I'm not hurting anything either, because it's, you know, I at least know that it is char and it has a pH. But so could I add that material to it as example, rock exits, slash mulch exits, or, you know, where the commercial, the truncated dome type exits? And the answer is yes. You didn't say yes. Now shifting gears, because it only gave me a little bit of time here. So now can I take multiple interesting fibers and put char in it for temporary soil covers? So when raindrops hit the earth and splashes, I'm preventing that, but if it did splash and detach metals or some other pollutant, it's staying locked into the mulch cover. Could it be done? Well, I'm already doing it. Industry is already doing it. And so you might call them, fun name, char mulches. You know, I'd give it a really scientific, engineering name. I want a char mulch. I don't want that straw mulch. I want the char one. Then you heard earlier that they take wheat straw and make a char out of it. Well, that might be. Then you put it in a mulch and add some other things like glues and so on. But now to outdo all of you, which is really cool, some of you talked about this, hydrochar. It's a liquid, and I'm adding a flocculant and hydrochar, and that's the intent. Now, these are exposed soils. I haven't got them stabilized. I don't have anything growing on them. I got to build that thing called the road. I mean, it's the whole point of being here, building that road, getting the bridges in. But I've got to stabilize the soils, but I can't always get it to the water treatment plant. So this is a way of perhaps locking that soils where they are, because I can't dig out to the center of the earth. I'd hit the iron core that's molten. Next thing you know, I'd have a volcano coming out in Minnesota. So you can't dig these pollutants out completely. So the idea, can I keep them there and then entomb them with the topsoil? You may not like this answer, but what do you think I'm supposed to do with it? Any idea how much it costs to take regulated and contaminated soil someplace else? really a strange expense. And then I use for char dewatering filter media. So, these are different things, but I could add the char into logs, water goes through it, it'd be other chemicals combined with it. It isn't just char alone, it's just char and a suite of things to try to deal with my arsenic and my mercuries and my VOCs and the oils and all sorts of things. But just to give an example that I could add these things, or I could take char logs and add it as synergy with other BMPs. There might be a log right into the rock, and that's to keep the log from floating away. It might be right into the topsoil, it might be blended into the topsoil. Then all that gets eventually disposed of, and I can, for dewatering, going through these series of baffles and have char as baffles. But the baffle has to be something I could buy, put in there, and then ideally, did it work or not? And everything is about $250,000, maybe $300,000 to get 2 years of study. In the meantime, world has gone on. This is an example of dewatering where this is a layer dewatering, so we're trying to use fabrics, rock, flocculants, and this is where I haven't done it yet, but this is where the char would go in one of those layers. You have rock, a geotextile, wood chips, a whole bunch of layering things that would be dewatered on this before it goes into the Stormwater inlet, which is right by that cone over there, which is right a direct connect to the Red River. So right now I try to use the logs, but it'd be nice to use raw char and just put it as layers. This whole thing comes apart. And even if it worked, and even if I didn't get it all picked up and it ends up where I'm growing sods or native grasses and stuff, is it the end of the world? You say no. It isn't. And I even have a device that looks like this. So this would be adding that same media we talked about. You asked what rate. Could I take something like that and have the icky water go through an upwelling sand filter, then get to the top and spill over, maybe have another char log as part of this, what I'll call the flow stream or the treatment train. But how many think an upwelling wetland using char would be pretty cool? So literally taking the dewatering dumpster, done it lots of times, and force the water up through sand filter media to remove the pollutants of concern. We know about them. And then, now this is not temporary anymore, but I really like to use chars for permanent stormwater quality, and this is actually building your rain gardens. So this would be where you'd ask the question, and this is literally an example of the proposed media. We put it in a 55-gallon drum, no bottom, so we let it drain. We run it through to verify that I get the flow rate before I put it in the hole. So there's drain tile here, your rock, it's like an umbrella. Then this whole thing gets filled up, and you never know what we did because it's all hidden. But the point is, I've got to verify it works. Oh, he's telling me to fast. And so I'm going to use it. This is what I'm proposing. We're proposing to use it as in-slope absorber. So the first 12 feet, I've only got like 1,200 miles built every year, so I can get 1,200 miles, 12 feet wide, 1 inch thick. Wouldn't that be a lot of char? And then just trying to show it how it could be and adding char and all sorts of groovy cool things. Add it into my compost, vegetated riprap stuff. And ultimately, someone has to write the dumb spec. Someone has to do the engineer's estimate, migrate the material into a standard spec, and so forth and so on, because I'm out of money. And someone actually has to make money. Isn't that weird? We live in a capitalistic thing. We should have money. And if you haven't done this, here it is again. And then I've got to go.